All right, welcome to week 6. We're starting the applications of integration, and the whole one of the big things that we study in this is the area under a curve, and then we use that to find the volumes of shapes. So let me give you an example here. Let's say that we wanted to find the area under this curve between 0 and 5. That's just um, uh, the square root function there. Okay, that's what you were doing with like definitive or definite integrals in the last section. But once we find the area under this curve, what we're going to do is take that curve then, find its area underneath it, between it and that red axis, and then take that and spin it around the x-axis, creating a solid. And then what we can do is find the volume of that solid using the area under the curve that we would have found initially, finding that area. So that's where we're headed in this. That's one of the big powerful things of calculus, is finding the volumes of shapes that aren't nice like cylinders or cuboids, rectangular boxes, stuff like that, pyramids. All right, so today's lesson is very similar to what we did in the last section, finding the area under the curve. And we'll do it on Desmos. I don't know if you guys have your calculator at home, a TI-84. You can also do it on that. But basically, when we first started talking about the area under a curve, we did it by dividing that area up into little rectangles. And then taking the sum of those rectangles and adding them up. Now, that was only necessary when you didn't have a shape that you already knew. So, for example, if I wanted to find the area enclosed by the line y equals 2x, okay, which is this line right here, the x-axis, so this is one boundary, the x-axis is another boundary, and then the vertical line x equals 0 and x equals 4 are my right and left boundaries. Well, that's really no big deal on this because that's just a triangle. So I know the area of a triangle is 1/2 the base of the triangle times the height. Well, I can tell by this the base is 4 and the height is 8. And so I get an area of 16. Well, then the next thing that we did was we divided this thing into little rectangles, and the rectangles were either taller than the line, and the more rectangles we had, the more accurate our sum was, or the rectangles were below the line, and the more rectangles we had, the more accurate our answers were. Well, essentially that's what integration is, except the rectangles are infinitely small. So if I wanted to do this exact same problem but using integration, I could write, I want to find the integral of 2x. So the area that is bounded on the top by the equation 2x, bounded on the bottom by the x-axis, and on the left x equals 0, and on the right 4. All right, so we do our integration here. So I get 2, and then this would be x squared over 2. And I want to evaluate that from 0 to 4. All right, well, these 2's will cancel, so it's just x squared. So it's 4x squared minus the lower bound, 0x squared, and I end up with 16. All right, so obviously using just a geometric formula would be simpler here. okay, that as opposed to using integration. But a lot of times the curve, the area that we get under the curve, between the curve and the x-axis, isn't a nice geometric figure. All right, in this case, we have a parabola, and we want to find the area that is bounded by the parabola on the top, the x-axis on the bottom, the x equals 1 on the left, and x equals 2 on the right. Now, we don't have a geometric formula for this shape. It's almost a trapezoid, but there's a curve there. So we can do it using a definite integral. In this case, our integral would go from 0 to 1. Okay, and now we integrate that. And we evaluate that integral from 1 to 2. Okay, so that would be 2 cubed divided by 3 plus 2 minus 1 cubed divided by 3 plus 1. Okay, so we got 8 thirds. So now it's just a matter of doing the arithmetic. Plus 2, so I'm going to make 2 into 6 thirds so that I can add those two. Minus, and then I got 1 third plus 1, and I'll turn that into 3 over 3. So I've got 14 thirds minus, let's see, this would be 4 thirds. So altogether, I end up with 10 thirds, which is 3.3 repeating. There's my integral. Okay? All right, now remember, all right, we've got an area here that is underneath the x-axis. So when we integrate it, it's going to give us a negative answer. Since the question is asking us about the area that is enclosed between this curve and the x-axis, we express area as a positive value. Right? So you have to understand, you have to know if your graph is above or below the x-axis. Okay, so this says find the area enclosed by x squared plus 2, and this is supposed to be, is a typo, it should be minus 2. Okay, and we want to find what's the area bounded by the x-axis, by the curve, by negative 2 to the left, and positive 1 to the right. So you integrate from left to right. Okay, so our integral now okay, so we substitute in 1, you get a third plus a half minus 2 minus, plug in negative 2, negative 8, positive 4 over 2 minus negative 4. So plus 4 there. Okay, get a common denominator. That's going to be 6. And so our numerator here will be 2, 3, and 12. So that gives us negative 7 over 6 for that portion. And then over here, we got negative 16 plus 12 plus 24. So that gives us negative 4 plus 24, 20 over 6. And now we do that subtraction and we end up with negative 27 over 6, which would be negative 4 and 3/6, or negative 4.5. That's the integral. But the area, the answer to the area here would be positive 4.5. Okay, so keep that in mind. If you did this integral on your calculator or on Desmos, it'll give you the, if it's underneath the x-axis, it's going to give you a negative answer. So on Desmos, I shared this with you. Now you can integrate lots of ways. This allows you to type in the function and then use sliders to change the two bounds. Okay, you can always just open up any old Desmos and just type in the integral as well. So to find the integration symbol on Desmos is under functions, and you click on miscellaneous. All right, so we were going -2 tab 1, and then our equation x squared plus x minus 2. You got to put this in parentheses, and then don't forget the dx. And then enter, and there's your integral. All right. Now, if you're doing area, one thing you can do is just put your integral inside of absolute value bars. Okay. I don't know if we have absolute. Yeah, I'm sure they do in here. I think it was ABS, if I remember right. Let's see. ABS. Yeah. ABS just does the absolute value. So now that's area. It'll just make, if it's a negative value, it'll make it positive. Okay. Now the file that I shared with you, you can type in your equation right here, x squared plus x minus 2, and then adjust your a and your b. So we had -2 to 1, there it is, and there's your area. Okay, if I absolute value this guy, whoops, ABS, no, it's not understanding me. I think I needed y equals AB. Oh no, I needed f of x equals that. Just a matter of how you type it in, guys. There it is. Now I'm going to go ABS. There it is. Okay, so that's the area. ABS just takes any negative portion and flips it over the x-axis and makes it a positive. If it's a positive portion, it doesn't flip anywhere. Okay, so that's the other way you can do it there. Alrighty. Example B, find the area enclosed by one arch of y equals sine 2x in the x-axis, and then two arches. So the first one wants us to find this area right here. Okay, so I graphed it over here on Desmos just so we get a quick look at it. And now, if I wanted pies to be on the x-axis, I would just go to Graph Settings, go to the x-axis, and just change my steps into a factor of pi. So, like pi over 6 works. I'll just do pi over 2. And notice how it puts the pi. It's now in terms of pi. Okay. So the area from 0 to 1, or from 0 to pi over 2, is equal to 1. All right, that's this answer. That's this right here. Okay, then after that, it says, what's the area under 2? Two of them. So that's where I'm going to, now B is going to go to pi. So I just type in pi. Okay, now when you look at the value, it's 0. That's the value of the integral. The area would actually be 2. All right. So like I said, if I ABS this, ABS, now you can see how the area changed from 0 to 2 because it's asking about area. When you calculate an integral, it's giving you the net area, which means if there's a negative portion, it's going to subtract it from the positive portion. Okay. So if we were doing this old school, all right, we would be going from 0 to pi over 2 sine 2x dx. So I could use substitution here. I'd let u equal 2x, du equals 2 dx. Take the derivative of both sides, solve it for dx. Now we can do our substitution. And du would get, dx would become this. All right, that 2 there is really a 1/2 that can come out front. And I can, when I integrate sine, I get cosine, negative cosine, and then I'm going to substitute my u back in. That's really negative cosine u, but I'll put the 2x back in. And then we evaluate that from 0 to pi over 2. Okay, so we first, so when I do this, I can keep the 1/2 out till I'm all done. So I'm going to substitute in pi over 2. So I got 2 times pi over 2, which is pi, minus, now substitute 0 in, cosine 2 times 0, all right, cosine at pi is equal to -1, so this is -1, and negative makes that +1. Okay, cosine at 0, that's 1, so I got -1, so that's +1. And then I got 1/2 of 2, which is 1. Okay, so that's the area under one arch. Now, if I did it under 2 arches, okay, these two areas are going to be the same. Okay, everything is going to look the same on this, except I'm going to go from 0 to pi. And now if I would do this, I would get, instead of getting 2, I'm going to end up getting a 0. So I need to realize that this area and this are the same. So this is going to have an area of -1, which means I think of it as a +1, and that's how I end up with a 2. Because if you just do the integral, you'll get the incorrect solution, because the question is asking you for area. Now, if it said, what is the net area, then 0 would be the correct answer. Okay? So when this guy gets integrated, I get cosine 2 pi minus negative cosine 2 times 0. Okay. Cosine at 2 pi is 1, so that's -1, minus, okay, cosine at 0 is 1, so I got a -1, that'd be +1, and you see how you get 0, but that would be incorrect. So you have to be aware of when you have a portion of the integral that is negative. All right, folks, that's it. Next, tomorrow, we do 2 curves. All right, so we'll have, instead of having a curve and the x-axis, you'll have one curve and then a second curve, and you're finding the area that is in between those 2 curves using integration. All right, take care. Good night.